Hello again, 7th graders, and welcome back to my YouTube channel. Be sure to subscribe and smash that like button at the conclusion of this video. Today we're going to talk about Bezout's lemma. Bezout is a French mathematician who postulated that, that if the greatest common factor of A and B is equal to D, and that's this statement right here, and obviously we're talking about natural numbers, okay? So if that's true, there's going to be relatively prime, that's the key there, relatively prime natural numbers, h and k, such that d plus h times a equals k times b. Okay, maybe that makes sense to you, maybe it doesn't. Let's try putting that into motion here. Consider, on this particular problem, d would translate to 2. Think of a as the 4, b as the 14. How's that? So, yeah, that kind of makes sense. I mean, we can see that the greatest common factor of 4 and 14 is equivalent to 2. Well, what Bezout's lemma promised us here is that there's going to be two numbers, h and k, that would fit, well, this formula. And those numbers will be relatively prime. So, if we were together, we could sit there and talk about this for a bit. I'll just go ahead and spoil it here. 3 and 1 will work. So you drop a 3 right here and a 1. 1 times 14 and 2 plus 3 times 4. Yeah, that matches. Cool. But so will 10 and 3. I could drop a 10 here and a 3 here. 3 times 14 is 42. 10 times 4 plus 2 is also 42. But again, these number pairs that I'm coming up here, 3, 1 and 10, 3, these numbers are relatively prime. Here's another pair that works, 17 and 5. Pretty soon it should emerge that these numbers that work happen to differ on the h side by 7 and on the k side by 2, interestingly enough. Make sense? So I could continue this list if I wanted to without doing much more in the way of calculation. I can just keep adding 7 on, and over here I just keep adding 2 on, and I'll know these numbers are going to work, that 9 times 14 will equal 31 times 4 plus 2. It'll have to work. Okay. Now if you have 15 and 26, their greatest common factor, of course, is 1. So by Bezout's lemma, we can write 1 plus h times 15 equals k times 26, sure. And so again, we can come up with some numbers that will make this true. Incidentally, by the way, I could have swapped this out. I could have had 26. I could have had 26 right here and the 15 right here. And I will still come up with pairs of relatively prime numbers, just to be clear. So, for instance, and on a problem such as this, you really only need to find one pair of numbers. In this case, if I go to figure this out, 19 and 11 will work. Okay. Yeah, it's going to take a little bit of work to try to find these numbers. If you're encountering a problem such as this, you're looking for two relatively prime numbers that'll work here for Bezout's lemma, consider possibly following that little piece of advice. That is to say, if I had h times 26 equals k times 15, you might find it a little bit easier to find numbers that work, namely 4 and 7, I don't have to dig too far, or 19 and 33, and so forth. Pretty soon, though, it should become apparent what's going on with these. That is, once I've unlocked it with one pair of numbers here, this is 15 more, this one's 26 more. Seeing the relationship now? K times 15, h times 26. See what happened there? Yeah. So with that, can you predict what's going to be another pair of numbers here after 19 and 11 that will work for this? If I said 19 and 11, right? Work. Well, what if I add 15 to this to get 26? And if I add 26 over here to this one, yeah, if I add 26 to this number over here, I make it 45. 45 and 26 will be a pair of numbers that work, as will 19 and 11, and so forth. This, incidentally, is an exercise that you will find when you're doing your EMF problems for today. And excuse me 1 second. Just got to sign back in. Here it is. Exercise 84. And there's a video that helps guide you through this. Okay? And again, they point out how they flip it around here, 34 and 18 and 18 and 34. yeah, try it both ways. But again, you'll want to watch the video to help you along with that. The other exercise that I'm going to ask you to do today is this little exercise. It's kind of another tea weighing exercise, if you will. And it's a little bit of problem solving. It says weigh out 1 ounce of tea using metal masses of 4 ounces and 7 ounces. Doesn't that seem unlikely, right? Well, consider how you can drag these masses onto the scale to make a package here. So if I do that right here, if I hit next, it says add loose tea to balance the scale. If I hit next, it'll add 3 ounces of tea over on the right. See, so now once I've done that, I've got a 3 ounce weight. Now, oops, not the 7, but the 4. So if I do it like this, now when I hit next, it made a 1 ounce package of tea. And so it tells me, I did that. It says put a 4 ounce pan. See, it actually puts the directions for doing this. And when I go to hit check, it says, yay, green check mark. There it is. Okay, so you're going to do that with 85. 85 is an easy enough one, right? 85, drop the 4, drop the 5, and of course it's going to make the 1 ounce package. That's pretty easy, right? So, is that clear? Then you go on to 4 and 9. But yeah, by the way, of course, if I hit submit on this one, it should work out just fine. And yep, gold star. So try it again for 86. I hope that makes sense for you. All right, so that's going to do it for this weekend. And again, there's the verbal directions, but hopefully what I just showed you makes sense. I will see you guys next time. Be good for your parents and have a great rest.